Okay, we are continuing with basic matrix operations, and we are up to example 4. It says solve the matrix equation for A, B, C, and D. All right, so when you look here, you see 4 times, this is in parentheses, and you've got two 2x2 matrices that you can add together. And then that is equal to another 2x2 matrix. So to start with, order of operations tells us to work inside the parentheses first. So I'm going to bring my scalar, my 4, along for the ride, and I'm going to go ahead and add the 2 matrices together. So I'm going to have negative 2a plus 3, and I'm going to have 5 plus negative 6, and I'm going to have negative 4 plus 7c, and then I'm going to have 2 plus 1. 2 plus 1 is 3. And then that is still equal to negative 28, B, 40, and D. All right, now I can multiply each element of the matrix on the left by 4. I have a scalar of 4, so I'm going to do scalar multiplication. So I'm going to have negative 8a plus 12. 4 times negative 1 is negative 4. And then negative 16 plus 28c. And then I'm going to have 4 times 3, which is 12. So now I have this matrix is still equal to this matrix. All right, and I'm going to go ahead and use the space below here as well. So I'm going to have negative 8a plus 12 equals negative 28. So I can go ahead and solve this one now for a. So I'm going to subtract 12. Negative 8a equals negative 40. And then divide both sides by negative 8. And a equals 5. All right, once we find a, then we can move on to the next variable. The next one says negative 4 equals b. So that one's easy. So b equals negative 4. And then we have negative 16 plus 28c equals 40. All right, so let's do negative 16 plus 28c equals 40. So I'm going to add 16 to both sides. 28c equals 56. Divide by 28. C equals, is that 2? Or is that is 2. All right, so C equals 2. So we've got A, we've got B, we've got C. So what do we have left? We have 3 equals D. So D equals 3. And that's it. That's A, B, C, and D for this first matrix equation. All right, I'm going to erase this, and then we're going to look at the next one. I want you to go ahead and take a moment and see if you can get started on this one on your own. See if you can work through, see if you can find A, B, C, and D, but if not, see how far you can get on your own using the similar steps. All right, let's look at the second one here. Okay, again, I've got 3 times in parentheses. I've got 2 matrices that are being subtracted. They are the same dimension, so I can subtract them, and then they're equal to a third matrix. All right, so let's start. I'm going to start up here. So I have 3 times, and then I'm going to have 2 minus 8, which is negative 6. I'm going to have 4 minus 0, which is just 4. 2c minus c. 2 minus 1 is 1, so just c. And then 2d minus 5. All right, let's move my 4 over a little. All right, so there is my matrix on the left, and that's going to be equal to A, B, and 9 and 9. All right, let's go ahead and do scalar multiplication. So 3 times -6, -18, 3 times 4 is 12. 3 times C is 3C. And then 3 times a binomial, I have to multiply by the whole thing. So pretend like that's in parentheses. So it's going to be 6D minus 15. All right, from there, I'm going to still have my other matrix. A, B, 9, and 9. All right, then I'm going to set corresponding elements equal because I have two matrices that are equal. So -18 equals A. All right, so that's my A. B equals 12. 3C equals 9. So C equals 3. And then I've got 6D minus 15 equals 9. I'm going to add 15. 6D equals 15 plus 9 is 24. And then divide by 6. D equals 4. All right, so we were able to find A, B, C, and D again. So I hope you don't find that too difficult. I hope you were able to work through those on your own even before I did it for you. All right, another way you can simplify the left side of the equation by first using the distributive property to multiply each matrix in the parentheses by 4 and then adding the resulting matrices. So what it's saying, instead of doing inside parentheses first, which I did, I added these two matrices first because they were in parentheses, but it's saying you can take the 4 and multiply by each element in both matrices and then add or subtract after that. So in my opinion, that's like a little bit more work, but if you wanted to do it that way, that will produce the same answer. Example 5, modeling real life. A high school district track and field organization uses the same standard qualifying times for its district championships in 2 consecutive years. The tables show the numbers of boys and girls in 3 class levels who qualified in the 100-meter run in those years. Organize the data using 2 matrices, one for each year. Then find and interpret a matrix that gives the average number of boys and girls who qualify in each class. All right, so the first thing it says, organize your data into 2 matrices. And then it says, find and interpret a matrix that gives the average. Remember, to find the average of something, you take 2 things, you add it up, and divide by 2. So how can we do that in terms of matrices? All right, so we can see that here we have qualifying times for 2019 boys and 2019 girls. And we also have 2020 boys and 2020 girls. All right, so organize the data into 2 matrices, one for each year. So we need to have a boys and girls. So let's do matrix A equals, and let's see, we've got boys and we've got girls. And let's say this is for 2019. Okay, so this will be 2019. All right, so 2019, so the boys were 18, 23, 16, and the girls from 2019 were 21, 22, and 24. So we can say that's class 1, class 2, and class 3. Now we can do a matrix B. Let's do boys and girls again. This time it's going to be 2020. And it's still going to be class 1, class 2, and class 3. So 2020, we've got 16, 25, and 12. That's for the boys. And the girls are 15, 18, and 18. So, wow, it looks like in 2020, the girls' time is faster than the boys' time. That's impressive. All right, so organize the data into 2 matrices, one for each year. Okay, check. That's done. And then find and interpret a matrix that gives the average number of boys and girls who qualify in each class. All right, again, to average 2 things, you have to add them together and then divide by 2. So the first thing we're going to do is take these 2 matrices, 18, 21, 23, 22, 16, and 24. And then we've got 16, 15. All right, so we're going to add them up. All right, and then to do the average, we divide by 2. Well, we don't really divide matrices, but we can multiply by 1/2. Multiplying something by 1/2 is the same as dividing by 2. So we haven't talked about division across matrices, and that's because we usually just multiply by the fraction. So let's add these together. So 18 and 16 gives me 34. 21 and 15 give me 36. 23 and 25, 48. 22 and 18 is 40. 16 and 12, 28. 24 and 18, 42. All right, bring my scalar down. Now I'm going to do each one of those times 1/2. So what's half of 34? Half of 34 is 17. Half of 36 is 18. Half of 48 is 24. Half of 40 is 20. Half of 28 is 14. And half of 42 is 21. All right, so this matrix represents the average number of boys who qualified in each class. Oh, so I was thinking these were their times. Okay, these are not their times. I was going to say, whew, those are pretty slow times for the 100 meters. But that's how many boys and girls actually qualified from each division. That makes a lot more sense than that being their running times. All right, so this is the number of boys and girls who qualified in class 1, class 2, and class 3. If you want to label those, we can do that. You can say that there are 17 boys and 18 girls in class 1 that qualified. There are 24 boys and 20 girls in class 2 that qualified, and 14 boys and 21 girls in class 3 that qualified in the 100-meter dash. All right, that's all for this lesson. If you have any questions, please let me know.